Afternoon, good evening, good morning, depending on the time you are watching this video. It is ELE 316, our second video. We are discussing network synthesis, and then, in the first video, we compare network synthesis and network analysis. For network synthesis, we said when you are given excitation and response, and you are required to find network. That is a network synthesis problem. For network analysis, you are given network and excitation. You are required to find the response. This is the network analysis problem. Now, there are differences. First, network analysis, you will have what we call unique solution. In network synthesis, the solution meaning there can be several solutions and there can be no solution. In network analysis, there will always be a solution, and the solution will be unique. If 3 of us, 5 of us are doing network analysis, we are going to get the same results. But in network synthesis, there may be no solution. There may be several solutions. My solution can be different from yours. So we should understand this, that in network synthesis, you may not have a solution, and then you may have several solutions, and then my solution can be different from yours. But in network analysis, the solution is going to be unique. It's going to be the same solution. When we say the solution is not unique, we mean that what we are giving, excitation and response, there can be several networks that can obey, that can behave with that excitation and response. But for network analysis, once we are giving a network and we are giving an excitation, the analysis is going to be the same. There is going to be only one solution. So let's take that into consideration. Now, but our main subject here is network synthesis. Every element, every circuit, every network has a mathematical expression or model that describes it, Every element, every circuit, every network has a mathematical expression or model that describes it. Not every mathematical expression can be realized as a network. Not every mathematical expression can be realized as a network. So that's why we need to study the properties of mathematical expressions, the ones that can be realized by network. We're going to study that in more details later. We said you may not have solution. If you are giving a mathematical expression that cannot be realized by a circuit, by a network, then there's not going to be a solution to that. Now, if you are giving an expression, let's talk of impedance. Your expression can be representing impedance or admittance. Remember that admittance is the reciprocal of impedance. So let's play with some expressions that can be realized as a network. Suppose you are giving Z equal to 2. Obviously, this must be a resistor. This must be a what? A resistor. A resistor 2 ohms. Suppose you are giving an admittance to be 10. Obviously, this is a resistor 2, and the resistance is going to be 1 over 10 ohm. The resistance is going to be 1 over 10 ohm. Remember that an impedance is V over I. We are working the time domain. And admittance is I over V. We are working in the time domain. Suppose we are giving Z equals 2S. Definitely this is a what? This is an inductor. This is an inductor. And it's going to be 2N. So when we are given any mathematical expression, we need to decode it and tell us what circuit it represents. Suppose we are giving an admittance to be 5S. This means what? This must be a capacitor. And the capacitance should be 1 over 5 farad. Hello. In video 1, you have been given expression for resistor, inductor, and capacitor. You have been given expression for it. So you understand what we are doing. Suppose you are giving Y to be 2 over S. That would be what? An inductor. And that would be 1 over 2 Henry. Suppose we are giving an impedance to be 1 over 20S. That would be a capacitor too. And that would be 20 farad. That would be 20 farad. So let me give you general expression before I go forward. If you have if it is an inductor, if it's a resistor, then Z equals R. Y equals 1 over R. If it's a capacitor, then Z equals 1 over SC. Y equals SC. If it is an inductor, then Z equals SL. y equals 1 over sf. You should be getting used to these things. Suppose you are giving this expression s plus 1, s plus 1, and you are told that it is it is an impedance. If it's an impedance, that means this will be a series connection of an inductor with a resistor. This will be 1 Henry and this will be 1 ohm. Suppose you are giving y equals s plus 1. Definitely, this will be what? This will be an inductor in parallel with a resistor. S must be a capacitor, that will be 1 farad. 1 must be, this will be 1. Hello, hello, take note of something. For impedance, when you connect with plus, that means series connection. Series connection. For an admittance, when you connect with plus, that means parallel connection. That means what? Parallel connection. So whenever you connect an impedance with plus, that means those two things are in series. When you connect an admittance with plus, those two things are in what? Parallel. So suppose you are giving y equals 3s plus 4. What would that be? You can interpret this as a capacitor, which will be 3 farad, and a resistor. That resistor is going to be 1 over 4 ohm. Hello? Because what we are giving here is admittance, not, so that will be, that 4 is conductance. So the resistance there is going to be 1 over 4. Suppose you are giving Z to be 1 over S plus 1. 1 over S plus 1. Will this represent anything? One over S plus 1. Suppose we are giving S over S plus 1. What will that represent? So you have to think. In the first book that I showed you in video 1, there's a table there that showed you all this. But I don't want you to memorize. You have to be able to get these things on your own. Suppose you are giving S over S plus 1. I guess This is likely to be a parallel combination of an inductor and a resistor. This is supposed to be a parallel combination of an inductor and a resistor. When you want to consider parallel, so, parallel is supposed to be, let's say this is S and this is 1. That parallel, when two things are in parallel, the impedance is going to be the product on top over the sum. So this is likely to be, so 1 over Z is likely to be 1 over S plus 1 over 1. So this will give us what? S is common, 1 plus S. So 1 over Z equals 1 plus S over S. And therefore, Z is going to be S over 1 plus S. So which means in this case, this is going to be 1 Henry, 1 ohm. Can we try this? Z equals 3S over 2S plus 2 plus 2. Let's say plus 3. Please, I'm working to the answer. So if that is 2S plus 3, then this has to be 6S. So if that is the case, what can you guess here? Which means this is in parallel. So this is supposed to be like 2 Henry. This to be like 1 over 3. 1 over 3. This is supposed to be 3 ohm. Let's see. So this is like 2S plus 3. So this is supposed to be 2S multiplied by 3 over 2S plus 3. That will give us 6S over 2S plus 3. So that is that. So when you are given any mathematical expression, you should be able to tell us what elements, what circuit elements will make that mathematical expression. Let's do one more. Suppose we have this. What element? You are not going to know straightforward. You just have to reason what will be it. But since I'm adding S square, there must be some, maybe there must be some capacitor. Am I supposed to have S square? Okay, let's leave this. Let's leave it. But whatever expression you are given, if I were you, work all possibilities. Suppose I have a capacitor and an inductor in parallel. What will be the Z? If this is SC, this is 1 over SC, this is SL. 1 over Z is going to be what? The reciprocal of this will give me what? SC. And the reciprocal of this is going to be 1 over SL. Take LCM. What am I going to have? I'm going to have SL. So this will be like S squared CL plus 1. So this is like S squared CL plus 1 over SL. So suppose I'm giving Z equals 4S squared plus 3 over 5S. How do I get the elements? How do I get the elements? How do I get the elements? So from here, if you compare with this, let me first divide by 3. This will be 4 over 3S squared plus 1 over 5S. It is already looking like this because I have 1 over 1. And that means this L must be equal to 5. L must be equal to 5. And then what I have here, which is 4 over 3, must be equal to CL. That means C must be equal to 4 over 3L. And since L is 5, this is going to be 4 over 15. So which means